To err is human is an age old excuse for sloppy work. Yet, while accepting imperfect products from others, we desire perfection. How can an imperfect human turn out a perfect product? Here is the formula: algorithm perfect, repeat until tested perfect, redesign, remake. 2 points are relevant. First, the test should be designed to truly indicate the desired perfection. And second, the repeat loop in our algorithm will repeat indefinitely unless redesign and remake could respond to or correct the errors found in testing. Understanding the art and science of testing allows you to attain perfection in your work, otherwise, an almost superhuman task. If you are a student now or were in the past, you are quite familiar with the word test and probably hate it. Understanding a teacher's point of view will help. The teacher sets a domain of knowledge for testing called the course syllabus. It may be the contents of a book, class notes, lectures, or some arbitrary combination of all those. Next comes the testing method. The teacher asks questions and analyzes the response, perhaps by matching answers to correct ones from the book. The quality of such a test system depends upon how well the test questions cover the syllabus. In VLSI testing, also, one should know the specification of the object being tested and then devise tests such that if the object produces the expected response, then its conformance to the specification can be guaranteed. Returning to our student analogy, since no one has infinite time, the number of questions must be limited and they should be cleverly devised. The teacher now makes certain assumptions. Certain typical errors, ones that the student is likely to commit, are assumed. Questions are devised especially to uncover those errors, and if the student's answers are correct, the teacher grants the benefit of doubt, showing confidence in the implicit error model. Electronic testing also uses fault modeling, and tests are generated for the assumed fault models. In testing, successful experience with a fault model gives it credibility, and eventually people expect reliability when a high percentage of the modeled faults is tested. Finally, remember that if you fail, you must repeat the course. This is similar to redesign and remake in our algorithm perfect. Of course, you can do better by asking your teacher right at the beginning about the course syllabus and error models, or what you will be tested for, and then plan your studies to succeed. In VLSI, that is called design for testability. Now let's talk about the role of testing. If you design a product, fabricate and test it, and it fails the test, then there must be a cause for the failure. Either the test was wrong, or the fabrication process was faulty, or the design was incorrect, or the specification had a problem. Anything can go wrong. The role of testing is to detect whether something went wrong, and the role of diagnosis is to determine exactly what went wrong and where the process needs to be altered. Therefore, correctness and effectiveness of testing is most important for quality products. If the test procedure is good and the product fails, then we suspect the fabrication process, the design, or the specification. If all students in a class fail, then it is often considered the teacher's failure. If only some fail, we assume that the teacher is competent and some students are having difficulty. To select students likely to succeed, teachers may use prerequisites or admission tests for screening. Distributed testing along a product realization process catches the defect producing causes as soon as they become active and before they have done much damage. A well thought out test strategy is crucial to economical realization of products. The benefits of testing are quality and economy. These two attributes are not independent and neither can be defined without the other. Quality means satisfying the user's needs at the minimum cost. A good test process can weed out all bad products before they reach the user. However, if too many bad items are being produced, then the cost of those bad items will have to be recovered from the price charged for the few good items that are produced. It will be impossible for an engineer to design a quality product without a profound understanding of the physical principles underlying the processes of manufacturing and test.